So we are talking about errors for this session. It's going to be probably a bit shorter than usual because it's a shorter topic, but it's still a very important topic. And there is actually a whole chapter dedicated to handling errors in Motoko in the chapters of the repository. So, oops. Okay, so let's get started. So I found it a bit confusing when I started, also because there are different types of errors. So when we say you have an error or like there is an error in my code, it's very important to understand what exactly the error is. Is it an error at runtime? Is it an error at compile time? Is it an error that is handled by the code, or is it a trap, or is it an error from the error library? So I've compiled 3 different types of errors, like errors that happens in Motoko. There are a few more than that, but I think those are the 3 main and the 3 most important. There are the errors from the result type. So, when we have this result type and then we have OK and we have error. So this one is probably the one that we encounter the most, but it's also, I would say, the good error because it's actually an error that is handled by the code itself and it's part of the normal logic of the canister. So it's like a good error. And when we see that, it's pretty easy to handle it. The second one, which is a real like bad error that you don't want to see usually, it's called trap. And so a trap is an error that can happen during the execution of a message, so the execution of a function, and cannot be resolved by the canister. So it's actually going to exit the execution of the method that you're calling and just throw an error, but outside of the canister. It's not the canister, it's the system, the IC that will throw you an error because you have done something that the canister cannot recover from. So one example of a trap would be to divide by 0 or to look into an array that is out of bounds. So if you have an array like with 5 elements and you're trying to look into element number 10, you have index out of bounds. And also with an assertion false is a way to trap. Sometimes it can be useful to trap, but most of the time you really want to avoid trapping. It's really not so great. And finally, there is another type of error, which is called the error type, actually. So it's a library. There is a library called error. And those ones are used with try catch and throw. And so if you are familiar with other programming languages, you know what is a try catch and you know how it works in JavaScript. It's completely different in Motoko, the way it works, because it's only for asynchronous operation. So I will explain exactly what I mean by that. But it's not how you are used to it in other languages. Okay, so with that in mind, we are going to see the 3 types of errors. I'm going to provide examples and situations where all of them, you can encounter all of them. So let's start with the easiest one, the result. And so we need to import the results library. Remember, this is something that is part of the Motoko language, and it's a external library, internal library. So the type result is a variant. We haven't properly had a session on variants, but a variant is a type that is a type composed of multiple different types, and a variant is one of those types. So for example, a result is going to be either okay or error. And it's used to propagate error across your code with the switch case, as we've already seen. So let's use the example from the repository. We have a type score, which is of type natural number. We have a type exam failed, which actually lists all the reasons why a student could fail an exam. So the first reason would be a score too low. The second reason would be that the student was absent, so he didn't pass the exam. Or the last reason would be that the student cheated. So that's also a variant type, as you can see. And we want to have a type called exam result, which is going to be a result if the exam is succeeded. So if we are in the okay scenario, we simply return the score, which is a NAT. If we return an error, we return the exam failed objects because we want to know why the exam was failed. So we return the specific reason. And then we are going to use this function. So yeah, this is like mm, so there seems to be an issue with the code. Yeah. It's missing the case here. So maybe we want to modify it so that we can actually store the, let's say, want to store the exams results. So it's going to be a hash map of score principal. So principal to score. Or maybe, well, more like a maybe like exam results. That would be more accurate. So this is how we define our hash map. And again, we need to import a principal. So that's already here. Okay, so I'm completely changing. I think the example was not so good. I'm changing the way it's returned. So I want to have a function that return my exam results. So I'm just gonna do that. Yeah, return exams.get color. And if we, I need to do a switch because maybe we don't have the. No, actually, this is good. I need to make that optional. And I can deploy that. Oops. The main is main.mo and the type is Motoko. And we have cold or canister errors. So right now, probably if I call this canister, there is no, I don't have any results stored inside. So it's just going to return a null object. Now I want to modify it. So this is where we see the power of results. We are actually able to handle our exam results. So this because this is an object of type result, we can actually switch on it. So let me show you. There will be two switch. The first one will be about do we get like some object? So is there something stored for us? Of course, as we've done before in the previous project, if there is not a project, we can return a text message. You have not taken the exam yet, so. And then if there is a result, oops, that's not what I wanted to do. So if there is a result, we can switch on it. So that's actually two switch case imbricked inside each other, intricated inside each other. So switch results, and now we can check. So case where we are in the OK scenario. So in the OK scenario, we are going to have the score, and we can return congratulations. Congratulations, you passed the exam with a score of, and then we can convert the score to a text. So we do not to text. Score like this. If we have an error, we can actually check which error is it. So if it's a score too low, we can do you failed the exam. If it's an error absent, you were absent. If it's cheated, you were cheating. So you can see the power of results, because when you are using results properly and you are using, for example, a variance for your errors, you can actually take care of it in your own code. And also you have to think about external developers. So in our case, we have, of course, we are doing everything inside our canister, but imagine that you have an interface where people can, query the results of exams of students. If you have a proper result type, other developers will be able to handle different errors. So they will be able to perform different actions depending on what is the error and which type of error is it. So for example, a good example would be if the score is too low, maybe we can also send to the user maybe some materials so that he can take the exam again. If it was a student that is absent, maybe we can send something like a questionnaire to ask him why he was absent, if he's not interested in the course, does he have problem in his life or whatever. Cheated, we can also send like a set of resource explaining that cheating is not good. So we could do all sorts of actions depending on the error, and we can only do that because we have defined a variance and we have defined a result. So when you want to perform actions and you have errors, use the result type. It's really good don't use like a custom type of error. Sometimes some developers they like to use custom errors. For example, they return 0 or -1 to indicate that something is wrong, and they define their own like code for like what each number mean, what each error represents. In Motoko, you have this result type that is very, very useful. So um, we can try it. Maybe first I will add another method. So yeah, that's fairly simple, but I just needed something. Hmm. Okay, so let's say I call the pass exam method. I will give myself a score of 100. That's great. And then if I get to call the get my result, congratulations, you passed the exam with a score of 100. So that's great. And yeah, so that's a good example for how to use results. And that's, as I said, the, oops, I thought we had, the second one is going to be the trap. And so the trap is more complex. Let me give you a good example for a trap. So we can take a look here. Public function will trap. So this function will trap. So let's say it's doing some computation. We have two variables and it's dividing by 0. And so this function will trap. We will never see this message. So because when we arrive at the line 50, because it's a trap, the execution of the message will be stopped. And so we are not able to see, and this will not be returned to us. So I can show you. The replica return a replica error, reject code canister error, reject message canister, canister ID, no, trapped, integer division by 0. So you can see, as I said, the trap is not our typical error. It's really like it's stopping the runtime of the canister, and it's the replica itself. So it's the IC itself that return an error. So it's like a more important or more profound error than the previous one. And so the trap can happen in the division by 0, but it can also happen when your index is out of bounds, or it can happen when you have an assertion that fails, or you can also use debug.trap. If you want to trap yourself, it's going to trap and also return an error message. So sometimes you might want to trap. For example, if I show you my code for the website of Motoko Bootcamp, so it's here. And And I've shown that just before. I have this concept of admin, and the way to kind of gate and create access control for my methods is to use this assert. So assert is something that is going to trap when oops, where is it? Yeah, here. Assert is going to trap when the condition inside the assert is not met. So if you have assert something and something is false, you trap. If something is true, you avoid the trap. So in that case, if admin.isAdmin, oops, of the color is true, we pass the assertion safely and we can use this method. If it's failed, so if it's not an admin, then this is going to be false and then this will trap. And so I can show you another example. If we do like, so what is my principal? Defix identity get principal. All right, so it's here. And we can define a variable, let principal admin of type principal is equal principal from text and this. And we can have this function is admin. So we have this function that can only be called if we are an admin. So we can try it. Defix deploy errors. And it's returning a welcome message if we are the admin. So no, that's not, it's is admin. So we are with the administrator identity, so it returns the message. But if we change our identity and I use, yeah, so let's say I use anonymous, assertion failed, and we even have the specific line where it failed, so line 50, which is this line. So it's exactly what's happening. Now, an important thing to know about trap, it's that, and for that I will need an example of like something like a counter. So variable counter of type nuts, public function increments. And then we have a query function, public query function, get counter. So get counter. Return the counter. And I need, okay. Defix deploy counter. So what do you think is going to happen if I try to call get counter? So I get the counter. If I try to call increment, we are increasing the counter and then we are trapping. So essentially we should be, we are going to increment and then we are going to trap. So we can see the error message, line 7, okay? But we have incremented the counter. So now if we call get counter, it should be equal to 1. But that's not the case. It's not equal to 1, it's still equal to 0, which means that this line either was not executed or something else happened. So what happens, what happened is that even though this line was executed, the changes were not committed. So this line was executed, and then this line was executed, and this line exits the message, exits the function, and all the changes that were previous to that. So even if we do something like counter is equal counter plus 100, 10,000 maybe, this is not going to be taken into account because as long as we are not returning from the function, the changes to the counter are not taken into account. They are not stored in memory. The only thing is, if we have some what's called a commit point. A commit point is a point in the code where changes and the state of your canister is committed, so saved essentially. And for example, let's say we have this canister which public function gets like greet public query func greet. It's just a simple method. I just want to have that. And then I have in my counter, I do let greet canister of type, so actor. It has a greet method, shared query, and it returns a text. And actor, and then let's say, so I'm not sure what is the canister ID. Okay, I need to go back to my identity. So okay, so I have this ID, I have this canister that I'm going to call here. For some reason, I'm just going to call this canister. I don't really know why I'm doing that, but it's just to give you an example. There is no specific reason. And then we have this. And I'm deploying the counter. Okay. So I have one canister that is controlled by Anonymous and the other is controlled by my other identity. Okay, so counter is at 0. Now, what do you think is going to happen if I call increment? So we are incrementing by 1, then we are calling this other canister, then we are incrementing by 1, and then we are trapping. So let's try. Okay, so it takes some time and then it trap line 14, so it traps here. Seems to be normal so far. And then if we get the counter, it's actually set to 1. So it means that this one was committed, but not this one. Every await in your code is a commit point. So essentially everything that goes beyond, like before that, like counter plus 1, every line of code here is going to be committed because we have this await. So it executes all the lines here, then commit the changes when you have the awaits, then you receive the message of the canister back, it resumes execution. It executes that. But it's not committed because we don't have a commit point here. We have an assertion, so it's executing and it's not committing. Of course, if we add another commit point, like we have a second grid, then this is going to be committed. And this is, oops, this will not be committed. So committed, committed. This is a commit point. This is a commit point, not committed. Because this is not a commit point, it's a trap. I hope this makes sense. And yeah, I hope it makes sense. So that's a little trick to know about trap is that you have to be careful when you're trapping after an intercanister call. Where is your latest commit point? So this concept of commit point is really important. And it can, yeah, it can get messy quickly. You have to think about it like very, very deeply. That's probably one of the most common source of error and mistakes that I would see in like codes of developers. They don't necessarily think about those commit points. And if you trap it, you can have your canister that is in a situation that you had not anticipated. Does anything else other than await and a function return causes commit points? No, that's the only cases. Yeah, so of course the return is a commit point. So whenever we return, it's going to commit. And this awaits, but I'm not aware of anything else. Let me verify quickly just to be sure about it. So it's actually explained in this document, which is actors and asynchronous data. Traps and commit points. Oh yeah, okay. There is one other error, like one other commit point, which would be a throw. So those are the points at which tentative state change and messages are irrevocably committed. Implicit exit from a shared function by producing a result. So for example, if we do just that, would also be like a commit point. We just don't specify the return, but it's the same in Motoko. So this would be a commit point. Await is a commit point, and explicit exit via return. So this is a commit point, of course. And this one I forgot about, it's the throw. So throw is also a commit point. Yeah, that's important to know. So we haven't talked about it yet. Now let's talk about try, catch, and throw. So now I will actually delete my whole example, my entire example. And I'm going to do something which is a bit strange, but I'm going to create a function trap, which only purpose is to trap. Maybe I can also, yeah, I just want to trap. And now I will call that the trap canister, which has a trap method, which is a shared function like this, which, yeah, that's the type of it. Let's remove that. We don't need it anymore. We don't need the counter anymore. Okay, so what I want to show is public shared caller function handle asynchronous error. Okay, so maybe we are calling another canister and we don't really know yeah, how it's not going to work like this. So maybe we are calling another canister and we are calling another canister. Of course, in that case, we know that the other canister is going to trap. We already know it because we have coded this trap. So it's pretty obvious that it's going to trap. But my question is, what is going to happen to our second canister? So this one, is this one going to trap as well? Or do we have a way to, handle it? And you have to think that in a real situation, you cannot know when the canister that you're calling will trap. Maybe it will trap for a reason that is out of your control. So let's try, let's say, naively to call that and see what happens. The fx canister call counter handle asynchronous error. And so we are not even able to call this method because the trap that is here is actually propagated here. And so we cannot even return that. So as you can see, it's failing my update call. So because of the trap here, I cannot even complete my method. That's slightly annoying because, I mean, I don't have control over the other canister because this is the canister of someone else. I don't have control over it. But at least in my code, I want to make sure that even if I'm calling canisters that are not safe or they have issues with their code, I'm not impacting my own code. And so to do that, to avoid those problems, you can use a try catch. And that's the only time you will use a try catch in Motoko. So for handling errors of other canisters, but as I will show you in a few minutes, the try catch doesn't work for your own. You cannot use the try catch to prevent your own trap. I will show you why. So let error not going to be, it's not going to happen. Yeah. So this line will never be executed because this is going to return a trap. And so we will be automatically propagated to the catch. And so catch return an error of type error. As you can see, we have the type here, error. And I can, for the first time ever, import this library and try to see how I can make use of that library. So if you go to the error library, the error type is the argument to throw and parameter of catch. So we have different type of error: system fatal, system transient, destination invalid, canister reject, canister error, future call error. So all sorts of different errors. You don't have to understand all of their meaning right now. But we have error.reject, which is going to create an error.code, which returns the code of an error, and error.message, which converts an error to a message. So we can actually use that. To receive some information about the error that we have just handled. We have catched the error. And now, if I call the function, which is called handle asynchronous error. This time it's properly named because, as you will see, we will take care of the error. So, oops, no, that's not what I wanted to do. Just like this. So, well, we don't have the error message that I wanted, but at least you can see that this time we don't trap, we just return, and our error, our trap is properly handled. And we can even have some information. Yeah. So we have the error message, but the error message is returned as a text and not as an actual error message like we had, where was it? Here. Yeah. So that's how you can handle problems from other canisters or like trap from other canisters. Now I want to show you that try catch cannot save you from your own problem. So let's say trap. We have a trap method. I don't know why we want to have that, but let's say we have it. Yeah, so that's a good example. Perfect. So if we assume that the try catch is able to catch our own synchronous error, then this piece of code would work. And so this would never happen. And then we would be able to catch the error and return the error just as we did before. But I've already spoiled you. It's not gonna work, as you'll see. No, this is not the good one. Handle synchronous error. So yeah, unfortunately, when you trap, if it's in your own canister, it doesn't matter if there is a try catch, you are not protected from it. So that's why we usually say that, well, that's why we say it's asynchronous error handling with the try catch. So it's only useful when you are calling another canister. And of course, we've seen a trap, but there are more issues that could arise when you call another canister. Maybe the other canister is not live anymore, so you have a canister ID, but it has been deleted and the canister is not there anymore. Maybe the canister doesn't has cycle anymore. That's possible. That's something that can happen more frequently than we think. The canister is out of cycle and it's unable to answer you. Or the canister trap because there is a programming, like a coding issue. Also, of course, the canister can also throw an error. So of course we have the try catch, but we can also use the throw. Like we could use like oops, it's not here, it's here. We could also how is the throw exactly? Let me see. It's like this error that reject. So it's a bit. Yeah, that would be like the manual way to throw an error. And of course, this can only be consumed by another canister through a try catch. So that's it for errors in Motoko. I hope you've learned a few things today. And yeah, there is not too much more to know, at least right now, on errors. Um, can you use await on line of codes that don't require an await so you can commit? Um, that would be no, that wouldn't be. I mean, you could do it, but I don't see a situation where that would be realistically a good option. If you want to commit, you can exit the function, so you can return, but nothing prevents you from returning and before returning, calling another function if you have more things to do. So that would be more adapted. But honestly, yeah, we need to see like an actual situation to 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 give a good answer to that. Is there a simple way to derive that color principal type thing? It looks like a destructured object. So yeah, it's actually a destructured object from. So I always use the. Sorry, let me go back to here to the counter. So I always use this syntax shared then color with the brackets because I destructured the object here. Actually, I will show you. So who am I? I just can just return the color. So this is the syntax I prefer, but actually you can also use this syntax, public shared and message. So this is actually the message that is sent to the canister. I'll call that who am I to. And then you can do message.color. The thing is that the message is an object that is accessible in Motoko, but the only property that you can access on the message is the color. I'm thinking that maybe in the future they want to add more information to the message object. So maybe it's interesting to keep this syntax like this. But honestly, like yeah, for my cases, I'll always do like this. So you essentially you're destructuring the object directly and just getting the color information. Are there only three reasons why you would trap yourself within your own canister, dividing by zero, calling an array, out of bounds, and assert? No, that's not the only reasons. I think those are like examples that I've seen, but it's not the only way. Um, just the most, I would say the most common ones are those one. But another one would be underflow or overflow. Like if you have a NAT, for example, a NAT is a natural number from zero to infinity. But if you do like you have a NAT that is equal to zero and you subtract 10 to it, so now it's like minus 10, but it's still a NAT, then it's going to trap and say underflow error. Your NAT is I don't remember exactly the message, but it's not going to work. Also running out of cycles and all sorts of problems could arise. I'm sure there are more that I'm just not thinking about. Okay. Well, we are on time. So it was a bit longer than I thought, but that's actually great. So we have the next session in 2 hours. We are building the project number 3, which is about a token. So I see everyone there and good luck. Keep building and have a good afternoon.